Welcome to the STEM Space at Home. I am Aerospace Engineer Claire Meschkat. Today we are going to talk about autonomous vehicles, robots, rovers, and how you can be a robotics engineer. Autonomous vehicles, or self-driving cars, seem like a crazy futuristic dream. But did you know that they were first designed in the 1400s? That's right, ingenious inventor Leonardo da Vinci designed a self-propelled cart that could move without being pushed or pulled. This design is even considered one of the first robots. Sadly, da Vinci's design of a self-propelled cart was never actually made in his lifetime. But in 2004, Italy's Institute and Museum of the History of Science in Florence built a working model of the cart. It actually worked. It works similar to the way that a wind-up toy works, where you rotate the wheels in the opposite direction of the intended motion. It winds up a spring inside and powers the cart. Experts noted that this design even looks similar to the way a Mars rover is designed. So how are the self-driving cars or autonomous vehicles being designed today? Let's head over to Southwest Research Institute in San Antonio, Texas to find out.
Hey friends, so you're probably wondering what you're doing inside of a car trunk right now. Hi, I'm Ridhwaan, and I work in the Perception Systems section here at the Southwest Research Institute. This car trunk here is just one of the places where I get a lot of project work done. Let me show you what that looks like. Welcome to the Southwest Research Institute. Here, we have over 3,000 people working on all sorts of projects, from deep sea to deep space. People have their expertise in all sorts of things. Some people have their expertise in mechanical engineering, or chemical engineering, or biology. Whatever their skills might be, they use them to make the world a better place, usually by doing one of two things. One, solving existing problems, or two, developing new technologies. What I do here is I work on something called perception systems. What does that mean? So, I usually see with my eyes and smell with my nose. Robots can't exactly do that. They have to use something called sensors in order to perceive the world. I'll show you what that looks like here in the lab in just a second. So by doing that, they get data into their computer systems, and then we manipulate them in clever ways to help them make sense of the world and act in a smart way. Let's go take a look. So, if you haven't already guessed from the camera shake, I'm currently on the roof of a car. And with me here, I have a very special type of sensor called a LiDAR. LiDAR stands for Light Ranging and Detection. How does it work? Inside this glass puck right here, there are a bunch of lasers stacked on top of each other, just spinning super fast and making scans of the environment. It basically takes advantage of the fact that the further something is, the longer it takes for a light beam to come out of this, hit it, and come back. And so it creates a 3D map of the environment. And what it does is it sends that to the computer of the car, which is basically its brain. I see with my eyes send signals to my brain, and I'm able to work around in the world. This car is able to see through this LiDAR. But this LiDAR is not the only thing that it can see through. Let me show you some other things. Alright, so here we are at the front of the car. This may not look like much, but it's actually a radar. So instead of using light waves like the LiDAR does, it uses radio waves. And instead of looking around the car, it basically looks in front of the car for different sorts of objects. It's pretty cool. The last sort of sensor we're looking at today is right over there. It's this camera that's strategically mounted right under the windshield and facing forward. The images that come out of that camera can be used for all sorts of tasks that include pedestrian detection because you want to avoid hitting people, for car detection because you want to avoid hitting those as well. Maybe you're looking at lane markings on the road so you can tell the car where to drive. These are just 3 sensors that this specific car uses to make sense of the world, but there are all sorts of sensors that people like to use. And this doesn't just go for autonomous vehicles, this goes for any intelligent system. So, today we talked about autonomous vehicles, but that is not the only type of intelligent system. There are all sorts of intelligent systems out there, but the concept is always the same. So whether it's underwater robotics or robotic arms gripping at objects and lifting them up, the concept is always the same. The sensors talk to the computer, which is the brain of the robot, and that brain tells the robot what to do. I wanted to say thank you for joining me in lab, and I hope you learned something today. See you guys.
Besides being really cool, autonomous vehicle technology is opening doors for humans to do things that otherwise wouldn't be possible, including exploring outer space. So who is behind these amazing designs? Robotics engineers. A robotics engineer creates robots or robotic systems that do things that humans are either unable or prefer not to do themselves. Through their creations, robotics engineers make jobs safer, easier, and more efficient. Over 8 rovers have now touched down on the surface of Mars and our own moon. They carry onboard instruments that collect data, such as panoramic cameras, spectrometers, and even magnets. 2 rovers, Spirit and Opportunity, on Mars have even found evidence of past water that could have supported microbial life. The Opportunity rover even set a record for extraterrestrial travel by moving more than a distance of a marathon. Today, you get to be a robotics engineer and create your own rover that can travel a distance carrying a rock sample. All right, engineers, before you create your rover, you will need to gather the following supplies. You will need scissors and tape, 1 coin cell battery, a vibrating motor, 2 bendy straws, a ping pong ball, a paper cup, and some construction paper. And I want to note before you get started that if you're using a coin cell battery, you need to be very careful and keep these away from small children. They can be very harmful if ingested. Before we dive into this challenge, let's talk briefly about circuits. A circuit is the path that an electrical current travels on and must include a power source, like a battery, wires, and some kind of resistance, like a light bulb or a motor. A closed circuit means a complete electrical connection around which current flows or circulates. An open circuit has been broken by an interruption and the electrical current can no longer flow around the circuit. When you flip a light switch on into the on position in your house, you are connecting a circuit. The switch goes from an open circuit to a closed circuit, and the current can then travel through the light to make it shine. In this activity, you will be creating a closed circuit by connecting your battery to the vibrating motor. You will first need to make a body for your rover. Then you will attach the coin cell battery and the vibrating motor like this. The vibration from the motor is what will make your rover move across a hard surface. Your vibrating motor will either look like this or like this. Either way, they work the same. Before attaching your vibrating motor to the battery, you will first need to strip off some of the ends of the coating to allow for there to be better connection between the wires and the battery. To do this, all you need is some scissors and to gently scrape off some of the exterior coating on each of the leads. Once you have a little bit extra of the wire exposed, then you're able to connect it to your battery. The blue wire will go beneath the battery on the negative side. Then you'll need to complete the circuit by attaching the red wire to the positive side of the battery. Once you do that, it will begin to vibrate. This is what causes your rover to move. There are many ways to design your rover using the materials that you have. Just make sure that when you complete the circuit from your battery to your motor, if you have this type of vibrating motor, you allow the end to move freely. It will spin around to cause the vibration. If you have this type of motor, you can connect it as you wish to whatever you design for your body of your rover. Then, when you connect the battery to the leads of your motor, it will cause the vibration and begin to move. Now for a real robot, you will have to give commands to it through computer programming to tell it what you want it to do. For this mission, your design is what the commands are to help your rover move along in a straight path. You will then need to construct a way for your rover to carry your rock sample, the ping pong ball. Now be careful that your rover body is strong enough to support the rock sample while still being able to move forward. To make your design, you need to start with the engineering design process. The first step of the engineering design process is to identify the problem. Your mission is to build a rover that is designed to carry a rock sample. Now, what are the constraints or rules you need to follow? 1. Use only the provided materials. 2. You must carry one ping pong ball a distance of at least 1 foot or 30 centimeters. 3. Use the vibrating motor to propel the robot. Next, brainstorm. What materials will you use to make your rover body? What shape will work best? Then, make your design. Draw up a plan based on your brainstorming of what materials you will use for each part and what your design will look like. Now it's time to build your design. Make sure that you attach your vibrating motor to your battery last so as not to use up too much of your battery power. Finally, test your design. Does your rover travel the correct distance? Does it hold the rock sample the entire way? If it does both of these, then it's a success. If not, that's okay. Redesign, rebuild, and test out your new rover design. If your rover is having trouble traveling in a straight line, you may want to do one of two things. You can make your design of your rover body more symmetrical, or you can add materials to one or both sides to make it more stable. Now you're well on your way to becoming a robotics engineer. Please share your rover designs on social media using the hashtag STEMSpaceAtHome and tagging us on Instagram or Facebook. Best of luck making your rover.